How's everybody doing?
Good.
Good? Okay, a couple in the front are okay. I've never been in front of a screen this big, so I have to selfie it. And the audience, hey! All right. So I'm here to talk about, I have my password problem just like Alex did. I'm here to talk about Ivy by example. As Alex said, Ivy's moving along. There's a couple of examples that we're going to show here. Not everything I wanted to show is going to be quite ready. So we've also added a little segment here for router updates since I work on the router. We're also going to talk a little bit about the router at the end. So as was mentioned, I'm on the Angular core team, been there for a couple of years now. I'm going to skip through this because we're a little bit short on time. And I'm just going to jump straight into debugging with Ivy. And I'm going to end up looking at my phone a little bit because I have to switch back and forth between the presentation and the examples. So my notes are over here. But from a developer's perspective, one of the first things that I think people will notice when Ivy lands is a bit of a better debugging experience. You saw some of the generated code that Alex showed. It's a little bit clearer, or can be a lot clearer than the existing view engine code, and to really see what's happening. Again, one of the reasons here is we don't have this factory file that sort of lives in between when we're debugging in Ivy. Also, the stack traces tend to be much smaller. So in the example that I'll show here, the stack traces are really short. Just kind of gets like right to the point. You're not bouncing around through a whole bunch of different files to figure out where your errors are. And most of the template errors can actually be reasoned about by looking at the generated code itself, right? With the view engine, you get this generated data structure. It's a little bit easier to reason about, imperative code that's actually creating DOM, or looks more like it's creating DOM in Ivy. And the last thing, I think it was maybe yesterday, there's some new debugging APIs that landed very recently, so we'll talk about that. Oops, I don't think we need this one. Who here has done AngularJS work? Okay, a whole bunch. You remember debugging AngularJS? You remember this API, Angular element? Anybody who's used that?
Oh yeah.
Yeah, right? You use that all the time. You can get your controllers, you can get like access to that scope thing that some of us remember. And we don't really have an equivalent for that in Angular today. Well, today we do. So there's a new API published on window called NG, and you can do things like get component, get directive, get the injector, etc. So we'll take a look at some of that stuff. So, all right, let's jump straight into a demo. And I have to find which one this is. Let me see here. Okay. So here we have just basically oh yeah, no problem. All right, how's that? The actual text here doesn't necessarily matter. This is sort of an example to-do app. We have this app sitting in the Angular repo. It's one of the applications that we use for sort of testing inside the Angular repo, make sure things are still working, make sure Ivy's progressing along well. And it's just your basic to-do app. I think most of us have seen an application like this, right? Who's seen these before? Okay, just about everybody. All right. So there's a couple of errors that are going to pop up in this application, but most of it kind of just works, and this is compiled with Ivy. But if I double click here, I'm supposed to be able to edit this to do, and we see here we get a relatively short stack trace here, and one of the really nice things about Ivy is that at least in the not obfuscated mode, you get names. I'll try to zoom in on this a little bit. You can see the name of the function that's being run, and it kind of makes sense, right? So this is the to-do app component. We went into a section, that's a tag, li, a tag, the input, and this is the template for the input. So just straight away from the name, we get a lot of context. But now if we click in to the actual code here, we can see that I think Alex showed how Ivy runs in sort of two modes. The first pass when the template is run is the creation mode, and the second pass is the mode that's going to update on bindings. So we see this variable here, rf, render flags, and 2. Down here is where we're doing updates. So this error didn't occur until we actually double-clicked and something changed, and now we're trying to read a new value. So if I put a breakpoint in here, and we do the same thing, we can see that basically the context, which is your to-do component, your actual component instance, that context doesn't contain this variable called Todd. It was a typo. So we can basically just fix that typo by moving the decimal point over. But one of the nice things here, I think, is that we can really clearly understand by looking at this template exactly where things are happening, right? So again, this is in the update mode. But we have another error that might pop up in sort of the creation block. So it didn't pop up initially, but when you're creating elements, you also want to wire up the listeners for elements. So if I type a to-do here, we've got an error that will fire if I hit enter twice. So if I come back to the console, and we come to look for the template here. So the error is occurring in stemming from to-do app component, the template, input, and the key up listener. So if we come back here, we're actually operating here. This listener was wired up during the creation mode. Again, we can put a breakpoint in here, refresh. That was the wrong button. There's me. We can do this. Okay. Refresh, and we can hit enter here. We can pass through, and I believe it's the second time that we hit this. No, sorry. We need to hit enter, and second time we do it after actually adding a value, we can step in to the component, to the actual component code here. We have an add to do, and it's reading this property, which happens to be null. So we get into the controller. We see that this is null in this case. Due to time, I'm not necessarily going to fix these errors, but you can kind of see how, coming from the template, you can sort of reason about where things are created, where the events are actually wired up, because you can actually see it in the code, as opposed to looking at factory files where you would be looking at essentially data structures, and the interpreter would run later. Okay, what I am going to do is play through this, and I'm going to show this new API. Who here knows Matthias on the Angular team? Okay. I think I was talking to you, Pete, about Matthias tends to be like right at the last minute, and sometime last night around like 2 a.m. his time, he said, hey, it's landed. So, so this is a new feature that just made it in there. And with this feature, you can do things like inspect element. So we're inspecting on the input element. And if you've got a handle on a DOM element, one thing that would be really nice to be able to do is just find the component that kind of controls this piece of DOM. So if we come over to the console $0 refers to the currently selected element in the elements panel. And if we use ng get component, we pass in an element. We'll assign that to a variable CMP. We actually get the component instance here. Now, just to prove that a lot of things that Alex said earlier about everything kind of being contained in the component, if we go component.constructor, so this is the class that you've created, or that's created, and the class that we get an instance of. If we go to ng component def, we can see all the things that Alex talked about earlier, right? We can see the factory. We can see the template function. We can see the selectors. We can drill in here. We can see that this to-do app is the selector, right? So everything is contained in here, and with this new debugging API, you can just get direct access to it. This API also has, there's a couple others. There's one for get component, there's one for get directives, there's one for get injector, and a few others. Okay. So, all right. So now, that's one thing on some of the debugging stuff. We've improved the debugging cycle, the powerful runtime debugging in the command line. I believe that my last statement here about source maps are coming is accurate, right, Alex? Yeah. So once the source maps support lands, you'll be able to go straight from your HTML rather than going into the Ivy output code. You'll be able to go from your HTML step into the Ivy output and then into your components. Makes it a little bit better. Okay. Now, this is the topic, lazy loading. I work on the router, and so lazy loading is something that I'm concerned with on a regular basis. But one question would be, why would we do it? Well, a lot of apps, you end up with lots and lots of files. These files become large. And most of your users don't interact with all of these files, all the JavaScript that you've written, at the same time. Most of your users are going to land on a home page. They're going to interact with that. They're going to transition somewhere else. That's kind of why we built lazy loading into the router. Additionally, it'd be kind of nice if you could do things like lazy load pieces of Angular, right? Maybe your homepage only needs Angular Common or Angular Core in order to render. Why load things like material and animations in order to just render that? So lazy loading today is handled by the router. We use this magic string, right? Load children, and that string is looked for by the compiler, and the code in order to do the lazy loading is output by the compiler. It's pretty complex to customize that process, and I actually had a slide of our documentation on it, but it was too small to show. We don't actually document very well how to customize it. Even if you wanted to, it's not documented very well, like how to do your own lazy loading implementation. So lazy loading with Ivy is a lot different. It works on standardized APIs, and one of the advantages there is we can use existing tooling. You don't have to go through something like the CLI. You could just use Webpack out of the box. Additionally, it's a lot easier to document. So there's this thing, dynamic imports, and it's documented, MDN documents it well. Essentially, it's the same as your import statements in ES6, ES 2015, but instead of getting access immediately, you get a promise returned. So the module will eventually load, and you get the value back here. So one of the nice things about that is you can use the await statement. You can make it look kind of nice. My widget component, we can do an import on my widget. And this is supported in TypeScript. So if you go to MDN, you'll see that you have to put the .js on there. All the pathing has to kind of work out correctly. But with TypeScript, as long as, like in this case, my widget is installed in NPM modules, or in Node modules, it's going to go ahead and be able to resolve the path. So this would be the first thing we would do in order to enable lazy loading with Ivy, standard APIs. And then I think Alex also showed this. We're going to have to get access to or resolve the component factory. In Ivy world, this is very simple, and it can be simplified in the future. For now, we would use the existing APIs. And we're going to use view container ref to create the component. So in the same vein as lazy loading, a couple of people have asked about this thing, dynamic builds. And dynamic builds would be a way to distribute entire applications, fully built applications, and let one application consume another complete, fully built application. So this might make sense on like really large teams where a given team really wants to have control of the entire stack, the entire build all the way through. Or another where maybe one app consumes another. Maybe something like adding a Hangouts application to Gmail. You could conceive that the Hangouts team would want to do the build themselves and distribute a fully bundled distributable file. So this becomes very easy with Ivy. Basically, loading of dynamic builds works, I say out of the box, it's almost out of the box. I was up late debugging this with Kara, and we found a problem in the instruction set. This is why some of the, the Ivy stuff, as we work on these examples, we find issues. But she was able to debug it quickly, so we do have a working example. Okay, so sorry, this is basically why it works, and we've kind of already looked at this. I think Alex talked about it enough. The fact that everything is local. We have this locality principle. The component itself contains all the information it needs in order to create itself. Okay, so let's do a little demo of this. So I'm going to come out here. This is a very similar to-do app. It's basically the same app, but we're bundling it much differently. So if we come into rollup here, I'm just going to output it as common.js for now. The hardest part about getting all this to work was just getting the bundling to work and getting the import statement to actually do what it's supposed to do. Ivy was pretty straightforward to get it to work correctly. But anyway, I'm going to do the common.js format. We're going to create a file in dist called to-do app. And in this little build file, after generating all the code, we're also going to output a packaged JSON file. You could do this in different ways, but I'm going to output this packaged JSON file so that I can npm install it into another application. But that other application isn't going to do anything. It's not going to use it. The compiler is not going to use any info from this to-do app in order to compile itself. So I'm going to run a build here. I'm in the trash. Sorry, this is to-do app. Okay. So we're just doing the basic bundling here, not compressing it, not doing any particular optimizations on it. And the build, we have a single file, which is our whole application. This is, again, no optimizations to it. It's 300 and something lines. It's about 16K, but there's tree shaking that could be done and optimization. And we publish the DTS files. It's important to publish DTS files so that on the other side, you'll see on the other side, we want type ahead. We want the consumers of these built applications to be able to get type ahead into our project. And a simple package JSON file. So if I come over here to, this is now a CLI app. And this is a CLI app where we're building with Ivy. So I should be able to do ng-serve and show the application. Okay. We'll blow this up a little bit. So there's just a button here. All that it doesn't look like a button much here, but it is a button. All that we're going to try to do when we click this button is go out and dynamically load this application that some other team has built, and we want to just drop it onto this page. Okay. At the same time, after we've dropped it onto the page, we want to not show the welcome anymore. We just want to show the to-do app. So if I come back into the CLI app. All right. So I'll come back in here. The first thing I have to do, actually, is I have to produce I have to simulate that we're on NPM. So I'm going to change into the dist folder, and I'm going to do an NPM pack. All that this is going to do is create a tarball that we can install in the other app. It's identical to publishing to NPM. It's the best way to guarantee that you're similar to publishing to NPM. And then we can do an NPM install to do app, dist, to do app, and we'll grab this tarball. This will go and install this other application in ours. And we'll turn back on ngserve. So our template here is very simple. We have a button with a click. We say load to do app. And inside of here, we want to import this application that we've now built. So if we come in here, we can do import. I'm going to just do my shortcut here, import to do app. So we're running the import function with a then on it. And we're asking for, by destructuring here, to get access to the to-do app component. And TypeScript is smart enough to know what this type is. We're not using it, so it grays it out. But it knows what type it is because it can follow this, this dynamic import and pull out the DTS files. So if we were to just save this right now, we're not actually going to do anything. But what we should see is that the then has run. And after the then is run, we're going to set to-dos loaded to true. And so the welcome should go away. Before we do that, let's just go over the network and make sure that we haven't already downloaded this code. When we click this, we get this file called Zone.js. Webpack has renamed it to Zone.js. But it is exactly what we had published on the other side. Okay? Does that make sense? Okay. So now we just need to implement taking this to-do app and dropping it onto the page. So the component factory is what we need. So we're going to get component factory resolver, and we're going to do resolve component factory. This is not this is an Ivy specific implementation. It's a very thin wrapper since we already have access to the component factory. It's already bundled in with this component. It's just sort of a thin wrapper. And then we're also going to run the create component code. So we're going to get the view container reference and create component. We're going to pass in this factory that we just created, or that we just got. And that should be all that we need. Hopefully it works. So we should be able to click Manage To-Dos. Again, we haven't already loaded anything, and we click this, and now the To-Do app is fully loaded. So this is a much different lazy loading experience than we currently have in Angular, right? Being able to do this type of lazy loading on an individual component by component basis is pretty cool. Like, you as developers would now have control over how you want to split your apps, and it doesn't just have to be by route, right? So I think this is awesome. Okay. Again, real quick, so it's standard based. We give the developer control. We give the teams flexibility of how they want to build. I think, Alex, you talked about some of this already. There's new stuff that will be coming with Ivy eventually. Things like dynamic template composition. You want to generate forms on the fly, things like that. Go ahead. Zoneless APIs will make it to make the zoneless experience much better. And I think, as Alex said, higher order components. This is an area that we definitely want to focus on. Okay, so that's it for now on the examples on Ivy. I kind of ran out of things that were working well enough to continue showing. So I'm going to really quickly, I have a few minutes left. I just want to talk about a couple of updates that we've done recently on routing, because I think it might be interesting. So first of all, why? We had a number of people that were having upgrade pains. This is really where it started from. We had applications, I'm sure some of you have this experience, that are stuck on an AngularJS router and the Angular router running at the same time, and both of them trying to read the global URL state and react to it. And it resulted in a lot of unpredictable behavior, really around like redirects and like if a guard were to fail trying to redirect somewhere else, there was a lot of really unpredictable behavior there. So one thing that we did initially was this thing, URL update strategy. Currently in Angular, we go through this process. We parse and match to the route. We run guards and resolvers. And then at the same time, in the same pass, synchronously, we both update the URL and we activate the route, which means we render it. We've added an option, and then after that, navigation and event fires. We've added an option when you're configuring the router to switch to this eager update mode. So the first thing that happens is parse. We then update the URL. As long as we know that it's a good URL, we go ahead and update it right away. After that, we make sure we find the route that you're supposed to get to. We run the guards and resolvers, just like we did before. We activate the route and render, and we do the navigation and event. The reason that this was needed was some applications have this use case of like, hey, I can't get to my page, but I still want the URL to represent the page I was trying to go to. Right? If a guard prior to this feature, if a guard were to fail, you can't land on the URL you're trying to get to and show like a 404. It's really, really hard. So this opens up that type of use case. And this is how you would use it. Router module for root, and you just pass the URL update strategy eager. Okay, I'm going to blitz through some of these other ones. Navigation, cancellation, and cleanup. So right now, we do something like this. We initially navigate. You click, say your user clicks a link. It's going to start running guards and resolvers. For really large apps, sometimes these can take a long time. While one is running, somebody clicks another link. What happens? Well, this guards and resolvers, these sets of guards and resolvers continue to run, but their result is ignored. However, the new navigation was waiting for those to finish. Okay? It's not less than ideal. We're in an observable world. We should be able to not have to wait and not have to just ignore the result. We should be able to just go straight to the new navigation and start the next set of guards and resolvers, and then activate the route. There were additional problems. What happens if during one of these guards or resolvers you were to perform a redirect? Well, now you've got something that's running asynchronously, say it takes 5 seconds, and in those 5 seconds somebody clicks the next link. Now there's a new navigation that got queued up, and then the old one, because the resolvers are still running, guard is still running and it fails, that one redirects you to a new URL. Now you're not where you expected at all, right? So this was a big problem. So what we've done is we've updated this by just sort of using observables a bit better. So when somebody goes through this process and they click that second link, we go back to this running guards and resolvers and we cancel it. So if you're using observables all the way through, it will fully cancel, it will stop the HTTP request, and it'll do a full cleanup. And so it's not just ignored, it's actually cleaned up. And so we immediately do that, and we immediately start the next navigation. So there's no longer this like delay that can happen if your guards and resolvers take a long time. That's gone. We also guarantee now that there's only ever one navigation running at any given time. So prior to this, there could be multiples running, and you could have side effects from those. So that's now fixed. So it's a performance boost, it's more predictable, and it eliminated a ton of bugs. And the last one, I'll go through really quickly, is we had a problem with guards. They run asynchronously. Multiple guards could redirect in one given asynchronous time, and the last one would win. There was no way to negotiate which redirect from a guard might win. So we've introduced a new API that guarantees priority of failures. And the API is specifically that you can now, from a guard, return Boolean or URL tree. So if you just do like a router.parse URL, you can redirect to login, and you can return that from your guard. What Angular will do is it will figure out the priority. Okay, so let's say you have all your can activate guards that might run in any given route, authenticated, authorized, and module is active. Well, you really care about authenticated most, right? They definitely can't get there if they're not authenticated. But if module is active, let's say, returns false first, we're going to wait because we know that these other two haven't returned a result yet. Okay, prior to this change, we would have just stopped execution on the first guard that returned false. But let's say authorized returns a redirect to /permissions. Well, authenticated still hasn't returned, so we're going to make sure that authenticated returns. If it returns true and it says, yes, you're authenticated, but no, you don't have authority, we're going to redirect you to /permissions. Similarly, if authenticated instead returned login, that's the highest priority. We're going to redirect you to /login. And if, just like as was prior, if the last one returns false and the earlier returns true, we're just going to cancel out the navigation. So hopefully this gives you a lot more predictability with how your navigations happen. You can sort of construct things with this knowledge. For can deactivate guards, it's the same priority but in reverse. So it's from the closest to where you're coming from, and then it goes back up for can deactivate. And yeah, so it's good. We got a directly supported redirect API, reliable guard sequencing, and it's on master. I think we have a release coming today that publishes that. So 7.2, I believe, is released today. So, and that's it. Thank you.